Mercury, a mere rock compared to giants like Mars or Jupiter, hides secrets beneath the surface. Scientists have obtained these secrets with the help of powerful telescopes. They see something moving that they have never seen anywhere else. These revelations can lead to critical missions to reveal the terrifying truth about our world. We are not alone. Let's uncover the dark shadow that Mercury holds. This small, fast planet orbits the Sun faster than any other planet in our solar system, completing its orbit in just 88 Earth days. In the past, we knew very little about Mercury. Early telescopes were too small to study, and the planet's small size and rapid rotation made it difficult to see. As space exploration developed, scientists began to understand more about Mercury. NASA's work in the 20th century provided the first detailed images of Earth marked by craters. These pictures are just the beginning. New data from space telescopes have revealed that there may be unusual conditions beneath the surface of Mercury, which has increased the interest in science. This interest has sparked enthusiasm and skepticism in the scientific community. Some scientists, interested in the new data, think about the discoveries of Earth on Mercury, which may be related to the features of the Earth and other previously unknown features. Discussions have begun on other important projects to further study Mercury. The goal of these plans is to explore the planet in more detail, uncovering new information that could change our understanding of the solar system's smallest planet. There is hope, but caution is also required, as these programs become more aggressive with invasive studies that can disrupt the global environment. In this new focus, it is important to remember the broader context. Each planet in our solar system, including Mercury, has its own unique characteristics and history that allow us to understand planetary processes such as planetary formation and the effects of proximity to the Sun. As scientists seek to explore Mercury more deeply, they must balance their excitement for discovery with the long-term implications of their research. The idea of finding new data is exciting, but it is important that we continue by following the value of Mercury's environment. Studying Mercury is a tricky business, like trying to take a sharp photo while looking at a bright spot. Despite years of planning and advanced technology, scientists finally caught up with Mercury's path to the Sun. Not only does the intense light and heat of the Sun make it difficult to see the planet, it also poses a serious risk of damaging sensitive equipment such as binoculars. As a result, astronomers can see Mercury in short periods of time without damaging their instruments. Even the powerful James Webb telescope had to avoid approaching Mercury for fear of damaging the Sun. Problems are not limited to visual problems. Sending a probe to Mercury is a lot like sending it on a kamikaze mission. Approaching spacecraft must battle the Sun's brutal heat and gravity or risk destruction. Missions to Mercury are rare and short compared to other planetary probes that can last longer. Mercury orbits the Sun at a speed of 30 meters per second, making it the fastest planet in the solar system. This incredible speed complicates tracking and studying Mercury and presents daunting challenges for any mission that aims to land on or orbit closely around the planet. Only 2 missions have bravely targeted Mercury so far: NASA's Mariner 10, launched back in 1973, and Messenger, which followed about 31 years later in 2004. These missions represent our main sources of first-hand information about the planet. Mariner 10 was equipped with advanced tools like 2 telescopes, spectrometers, a magnetometer, and a plasma analyzer, essentially making it a mobile science lab tasked with gathering as much information as possible from its quick visits to Mercury. The probe cleverly used Venus's gravitational pull to alter its path towards Mercury, allowing for a series of flybys that revealed the planet's surface for the first time to us Earthlings. The images returned by Mariner 10 unveiled a landscape riddled with craters and strange ridges, much like those found on our moon. This revealed that Mercury had a rough and heavily cratered exterior, along with a surprisingly strong magnetic field and a larger core than expected, challenging what scientists had previously assumed about its composition. During its second flyby in 1974, Mariner 10 captured views of Mercury's southern polar region, offering new vantage points and data on this difficult-to-study planet. The mission concluded with its final flyby in March of the next year, which provided yet more data but still left scientists wanting more comprehensive information, a desire complicated by the technical and environmental challenges of studying Mercury. To date, most of what we know about Mercury comes from those 2,700 images and scattered instrumental readings from these missions. It's impressive in its own right, but it's also a testament to the complexity of space exploration. All the Mercury data is hard to come by, and it's a small victory for the vast and dangerous nature of our solar system. It shows how strongly we pursue knowledge about our neighbors on the planet in terms of technology and the harsh environment of space. Therefore, the study of Mercury is not only to quench our thirst for knowledge, but also to remind us of the difficulties in exploring the universe. Each new discovery is a step forward, but it shows how slow and laborious it is to see the intricacies of planets like Mercury. Next, we'll explore what happened after Mariner 10 and how its legacy led to new missions to explore lost lands. When the Mariner 10 spacecraft ran out of gas in 1975, the mission ended and it became idle. During its mission, Messenger completed 3 critical passes around Mercury and took over 200,000 stunning images. These are not just pictures. They captured detailed views of Mercury, including areas unseen by previous missions. The data revealed some interesting facts. For example, magnesium and manganese are very high on the dark side of Mercury. The discovery may have raised questions about the mechanisms contributing to these concentrations. In addition, the strength of the Earth's magnetic field is different in its northern regions, which is different from other planets. When NASA analyzed the data, it became clear that Mercury's unique magnetic field is due to its internal structure and how it was formed. On most planets like Earth, magnetic fields are created by the movement of liquid iron in the core. As the Earth rotates, the liquid iron moves, generating electric currents and creating a magnetic field. However, Mercury's internal structure is different, so its magnetic behavior is different. Messenger's observations are important because they provide a deeper understanding of Mercury. It's not just about collecting data for that. This knowledge helps scientists understand the formation and behavior of planets. It challenges previous assumptions and provides new insights that can be applied to other celestial bodies. This story of the discovery of Mercury is a story of human curiosity and technological progress. The journey from Mariner 10 to Messenger represents our progress in space exploration technology and our deeper understanding of the solar system. Each piece of data that Messenger brought back to Earth not only added to our knowledge
of Mercury, but also helped us see our planet in a new light. By studying Mercury, we learn more about the universe and our place in it, revealing the interconnectedness and complexity of the universe. As we continue to analyze and understand the information gathered by Messenger, we will build on the legacy of previous missions. Each discovery adds to the growing body of knowledge that informs future discoveries. The story of Messenger and Mercury is a symbol of the human spirit that is always exploring, understanding and constantly pushing the boundaries of what is known. Hawa at the University of California, Los Angeles, discovered something unusual about Mercury that surprised many scientists. Usually, in planets like Earth, iron changes from liquid to solid at the innermost part of the core. However, in Mercury, this change happens at the outer boundary of the core, which is not what was expected. This finding challenges the way we thought terrestrial planets behaved and suggests that Mercury has a unique way of doing things. In explaining this phenomenon, Hawa compared it to a snowstorm where snow forms at every level of the cloud, not just the top or bottom. This means that on Mercury, iron might be forming solids throughout the fluid that surrounds the core, affecting the planet's magnetic field in unusual ways. This discovery has important implications for understanding how magnetic fields are created on different planets, as it shows that the same ingredients can produce very different results under different conditions. Additional analysis supported by data from NASA's Messenger mission supports Hawa's findings. Even though they have similar elements like sulfur and iron in their cores, the planet and Mercury are very different. This discovery is a wonderful reminder that planets with similar compositions have different properties and characteristics. This understanding will change the way we see Mercury and may affect the study of other planets and their magnetic fields. The Genesis data and subsequent studies by Hawa and others show that our understanding of Mercury is still evolving. Each new piece of information helps us build a more accurate picture of this mysterious planet. Understanding Mercury's magnetic field, the composition of its core and how it interacts will help us understand more about the planets in the solar system and the processes that form them. By studying Mercury carefully, we learn about the solar system and the universe. This effort to understand our neighbor in the world is part of the human ability to explore, learn and understand the world. Each discovery adds to our collective knowledge and brings us closer to answering some of the deepest questions about the universe and our place in it. The way forward is more research and missions to Mercury. As Mariner 10 and Messenger set the scene, more advanced missions could unlock mysteries about the planet's interior and its unusual magnetic properties. As the technology improves and the challenges are better understood, future missions may delve deeper into Mercury's mysteries. This constant exploration shows the human desire and urge to go beyond the known boundaries and a constant search to find the hidden truths of the world. With each new data and discovery, we get closer not only to Mercury, but to the general principles that govern all planetary bodies in the solar system and beyond.